Hello, everyone. My name is Peter Oliver, and this is The Burning Question. I'm joined today by Andre van Zyl, who's the founder of New World Pavement Solutions. He's currently based in Australia. Thanks for coming on and chatting with us.
Thank you for having me, and thanks for, especially to you, for all the good work you are doing. The Burning Question is now doing the rounds here, and everybody is talking about you and your podcast. So brilliant work.
That's so kind. Well, so let's I think the work you're doing is really interesting, and I also think the way that you're talking about working with biochar and the scale and opportunities around carbon sequestration are really unique. And I want to hit on a couple points, but setting out kind of a table of contents for the people that are listening along here, because you have done a lot of interviews, and I mean a lot of presentations, and I'll link to some of those. I think I want to cover kind of your mindset around how you thought about kind of addressing this initial challenge and how you came to use biochar in your pavement business. And then kind of how you think about both carbon emissions from what you're actually putting into the road and the surface that you're using, but also the avoided emissions portion of that I think is really interesting and something that I don't hear much about. And then the last part is, we hear a lot about the kind of exciting future that biochar could have and perhaps will have, but we don't see so many companies scaling up and scaling up quickly. I'd love to hear about how you're planning and thinking through the next 12 months. So those are the kind of pieces we'll talk through, but let's first take the first part. So why don't you tell us a little bit about how you got to a place where you're using biochar as part of this company, as part of your product?
Thank you very much. It's again one of those things that you stumble on, because you need something that's not available. So traditionally, under the Carbon Core banner, we've been developing and putting cold premixes into remote and rural areas. It's an anionic-based product that needs a little bit of carbon to make all the special bonding mechanisms work properly, and it's a product that produced into loose bulk. It can travel for up to 2 weeks on the back of a tipper lorry. So that gave us the opportunity and the possibility to build roads in the middle of nowhere, mining regions, remote and rural areas. And then branching out into the first world, we got to the stage where traditionally the feedstock or one of the raw materials was carbonaceous shells or coal fines, unwanted coal fines. And in certain regions and areas, it was just not available. And we started looking at alternative carbon sources. And it's a small percentage of carbon needed in the product. But we started using coconut husk shells. We even looked at charcoal, which is not very environmentally friendly to use. And then suddenly heard about biochar and started doing investigation and research on what is this, where can it go? And then we got some, and we had to do some product changes. And
well, so let me hold on right there. So the arc that you've just painted is actually a pretty long one. I know from a previous conversation. So your company was previously, in previous iteration, was Carbon Core, and you guys focused basically on building roads, right? And is that fair to say? Yeah. And yep. So we heard you basically, from my story, from my previous conversations with you, it sounds like Malaysia and some other places in Southeast Asia were initial focus. When did you start incorporating biochar, and what, how has this happened? Is this 5 years ago, 10 years ago, 2 years ago?
No, I think the Carbon course on our side of it started out of South Africa, obviously, in the early 2000s, and then it grew into Asia, Vietnam, India. Mm-hmm. And in 2014, we started really taking the technology to the next level, and we put production plants up in Malaysia. And again, in Malaysia, in a monsoon rain type environment, inherent moisture contents of coal and carbon containing materials are quite a lot different than what they are in the drier regions of the world. So it's in 2014 that we started playing around purely based on the need of a product that contains carbon that we can use as a raw material. And to be quite honest, as a chemical engineer, people expect you to know everything sometimes. But in 2014, I didn't know what biochar was. I had to go and read up, Google, Wikipedia, what is this and where does it come from and how do you? And then the learning curve started very, very steep until where today, I think biochar has got so much potential. And although there is thousands and thousands of scientific papers and research and development activities around biochar, outside of the agricultural soil carbon application, nobody is doing anything to scale it up. And we just started on a mission now to see how much biochar can we get into a road product, being it a soil stabilizer or a wearing course or erosion control, spray seals, dust suppressant. I mean, we put biochar in everything now. The product itself, it's anionic, it's waterproof, it has UV inhibitors in it, suntan lotion for short. So there's a lot of performance related properties that make it better than most. By adding biochars, now you bring a different concept to the material. We are now able to do carbon negative installations purely by controlling how much biochar we put in. We need a certain small percentage for the technology to work, but if for like the mining industry, they come to us and they need some serious carbon credits here, and it's a cost factor. And I think one of the biggest hurdles in the world currently is the cost of biochar, because the current biochar industry needs a clean feedstock to, within a clean process, make a clean biochar that can be used to grow your tomatoes in it, or to feed to cattle fodder and all kinds of animal feedstocks. And there's people that's playing around with a little bit of modification on this biochar to get nutrients in there and to mix it up, combination fertilizers. I mean, the industry is there. But unfortunately, the volumes related to the current biochar industry is not nowhere enough to maximize that effect, that for every ton of biochar, you've avoided up to 4 tons of carbon dioxide emissions. So
when you help the people that are hearing your story for the first time understand, I had to kind of look up some terminology. You have kind of the wearing course, which is the top of the road, and then you have fill or aggregate under the road. Where does the biochar go in your product, and how much biochar is in, say, a kilometer of road?
Okay, that's where it gets interesting now, because on the agricultural side, I believe that well, we work with quite a diverse set of agricultural soil carbon related guys, being part of ANZPIC in Australia, the Australian New Zealand biochar industry group. We are, I think, one of the world leaders now in progressing this along. And the change came when the biochar, and I say this with respect, the conservative biochar community that always has to stay clean feedstock, clean this, they get up to, I think, 5 tons of biochar into a hectare of agricultural soil, which is significant. And there's carbon accounting platforms already running that and monitoring it and issuing carbon credits to farmers after a few years based on retained soil carbons, etc. Then we come along And in 1 kilometer of road, 2 lanes wide, just the wearing course alone, we get somewhere between 30 and 40 tons of biochar into that layer. And then we developed the technology to now also get include the biochar as a soil stabilizer. So we number one, we don't need foaming bitumen technologies anymore. No lime stabilization needed. It's purely a mixture of anionic special anionic binder mechanisms with biochar, and in the road base 200 millimeters thick, we get in up to 200 tons of biochar. So, you know, the goal now there is in 1 kilometer of road, 2 lanes wide, which is roughly the same area size as a hectare of agricultural soil. We get in up to 250 tons of biochar.
Yeah.
Now that's significant. The hurdle is the cost of the biochar. It does not make sense to go and put the clean stuff in the road, because with all these life cycle analysis with soil carbons and what happens to it, oxidation and acid rain, and how long does that little biochar particle live in the potato field? If you stick it into the road, it's there for, if you've done your city planning, right, it's there for thousands and thousands of years. And it's locked up. It's not going anywhere. It's we've done all the necessary leach tests to basically prove that we can even use not so clean biochar. I always, my head has been bumped a lot about the dirty biochar word, because it interferes with the agricultural, and they are our brothers. We have to walk hand in hand. So we tend to use the word, you know, not so clean biochar, but now it opens the door to go and pyrolyze or torrefy not only the clean wood chips. I know the last thing we want is for people to go and chop down rainforests to get clean feedstock for clean biochar. There is so much contaminated biomasses now. We can utilize biochar that comes from the biomass industry, sewage, all the leftover forest, half burned wood products, wood waste out of forest fire areas. We now can pyrolyze wood waste out of cities, construction wood waste that is normally treated with all kinds of nasties, and we can put that into the ground as a carbon sequestrator. The one thing also that is very, very important is the lowering the total amount of emissions. You know, the whole global environment that we live in now with global warming, and we're not going to solve it only coming from one angle. You've got to tackle everything at the same time. You've got to take your foot off the petrol, and you've got to put it on the brake. Otherwise, you're not going to slow down. Avoiding emissions is actually in our side of things is the most important thing. Laying roads where you need only that amount of thickness versus that amount, if it's the standard.
Well, so hold on. I don't. So this was all new to me last time we spoke, and I thought there's actually I feel like there are actually 3 things that you're talking about. So one, there's an interesting argument about trying to use feedstock that we can't use other ways, right? And perhaps could lower the cost of the processed biomass by using what is more akin to true waste, so things that people pay to get rid of, as opposed to relatively clean feedstocks like the industry with the kind of long-term intention of focusing on ag has done until now. And I think that's a super interesting point. We could probably have a whole conversation just about that.
Oh yeah, that's huge.
Then there's this idea of, you know, putting down carbon, right, and using roadways as negative emissions, right, as a place to put carbon and store it long term. And then the last part, which is what you're getting to now, and I think was totally new to me, I never really actually thought about, was avoided emissions, because as you're describing, making roads is really hard, and we currently do it all hot, right? So maybe you could break down like what goes into making a road now versus what's in your product from the factory to the finished road. Because that kind of, I was like, oh, maybe the avoid emissions are even greater in terms of tonnage than what's actually in the road. So
yeah, I mean, the interesting thing is here in Australia, they have a computerized Excel program called Carbon Gauge, and every tender that's done, you have to submit your total carbon emission footprint, and they've got the templates and the databases, and to crush and mine, to mine and crush aggregates, to clean it, to screen it. You know, there's values associated as per the carbon footprint or the emission footprint of that. And we always, well, not always, when we started getting into this, we thought that the transport of these materials, you know, well, out of all the emission footprints, the transport section of it, especially in a country like Australia, which is so big, we thought that'll be the biggest percentage, and we were totally wrong when we started doing the calculations. Just producing that aggregate is by far the biggest carbon emission footprint. So now, if you need to build a road, being it close to you or being it far away, the distance is not is not the critical part anymore. It is the aggregate that you're using. So the emissions coming from the raw material supply is by far the biggest. So now, if number one, if you can do a road base without, and normally, unless the soils are very bad, you don't need aggregates in there. But definitely for the wearing course, there's a very mixed design based particle size distribution aggregate that's needed. And
when you say aggregate, for people who are not in the industry, it's mostly kind of like sand, rocks. It's
rocks,
material, yeah. Right? Okay.
Yeah, it's granites or quartzites or whatever. Every country, you know, limestones and dolerites, and but that aggregate number one has to be in a very specific particle size distribution curve. So enough fines and enough coarse material to get it stable, and then they add basically 6% hot bitumen to it and give it a good mix and stick it around on the road. Now, in general, your conventional roads are 50 up to 90, and if it's high-speed roads, motorways, heavy duty, designed for 20, 30 years, then those layers are up to 110, 140 millimeters thick.
Wow.
So number one, we come
30 to 40 inches. Wow.
Yes. Yeah. You know, this metric system and imperial system still trips us up.
Sorry, we got to do the translation.
Yeah. So, but just imagine now, if what you normally need, you know, that thick, 4 inches, 5 inches of material, and you can now bring that down to 30 millimeters or 1.5 inch of material, because that's about the average thickness that we install the welding courses. And they on par, performance for performance. It's a different bonding mechanism. There's, you know, from a technical point of view, that's a separate discussion on why it's so much better. But it contains carbon. It's waterproof. It doesn't creep. It doesn't crack. It doesn't leach. We've done all the. It makes even not so clean things like dirty or not so clean biochar. It even makes that inert when we stick it in there. There's no leaching coming out, and so the emission, the savings of emissions of not needing all that aggregate, being at the production of that aggregates or rocks, or being the transport of it. The next thing is so much less logistics on site, because you're handling so much less material. No heat required on site.
Is it half? Like, can you compare the overall aggregate required for your road versus a standard road? About a third, right? So you can reduce just the cost of the incoming. I mean, just the carbon footprint of the incoming aggregate by 2/3. Yeah,
massively. And then the fact that we don't need solvents, we don't need heat. We use conventional installation equipment. Heat switch off, no heat required. Another big factor, which is becoming, and we've set up a very big R&D center here now in Perth as well. is the ability to take certain types of char and biochar, and we do a modification on that, that it actually, those particles becomes an aggregate. It's like a lot, you know, so we are now able to make lightweight or low density roads, and we've succeeded using pandan soils and, you know, all these desert roads. When you see the truck go by, it looks like somebody dropped a few tons of baby powder behind it. We can take those pandan and talcum based soils, and we add a modified biochar particle to that, and we build roads without the use of or the need of any aggregate. So now the biochar particles becomes the aggregate. Now that is a game changer, because you can now build roads in the middle of nowhere with the in situ soils. The only thing you have to take there is some modified biochar, and that's the reality. It is massive. It's not only about getting carbon and sequestrating carbon down in the ground. It's about stopping the emissions, minimizing the emissions. That's huge.
So this is, I mean, I really think what you're doing is very exciting. And I guess for people who, hear this and go like, okay, so we have a cost competitive, better for the environment product that's capable of producing negative emissions. Like, let's roll, let's do this. What does the next 12 months look like for you, and what does that mean for the local biochar industry in in your case, Australia?
Yeah, well, the first big thing that we had to do since last year, I actually got stuck in Australia because I couldn't go home because of COVID borders that closed up on us, and now Perth has become home. The first thing we had to do is try and take the difficult parts out of the equation, because we cannot travel there and go and show and go and train. So we plan for being able to hand over a product contactless or contact free. But we also, the next one then is to be able to manufacture and produce the products remotely without having the ability to go there. So we've done a lot of work on automation and redesign of manufacturing equipment, which is, it's basically standard hopper bins with puck-mold mixing systems, etc. And then a very specialized emulsion plant, so that the heart of it sits in the emulsions. That's the binders, that's the stuff that make it work. So we are now, over the next 12 months, we will roll out somewhere between 8 or 12 production plants.
Size are these production plants?
On average, we design them for about 65 ton per hour production. And the reason for that is, in one day, you can produce enough material to lay 1 kilometer of road. So, again, not using less aggregates, avoiding the emissions, but also, although the transport of material we've seen now against what we expected, the carbon emissions is much lower in percentage based on for the total picture. We still would like to minimize the transport of material. Transport logistics is, the truck goes that way, but it comes back empty. If you can maximize and backhaul, but it's not always possible. So we've come up now with, instead of building one big plant that can produce 3 or 4 or 5,000 tons of product a day, we've scaled down and said, number one, once we've produced it, you can leave it on a stockpile for up to 2 weeks. You don't have to. The standard hot premixes, if you've made it, you've got to use it. If it cools down, it's gone. So we have zero waste. We have very long truck life and stockpile life on the products. If we stick it, not if we do, we put it into 25 kilogram LDPE bags, and we export it to 14, 15 countries, and we build roads in the middle of nowhere. If we put it in 1 ton bulker bags, it has a life of 6 months. So it opens the door now for remote communities to do their own pothole maintenance repair. they don't have to wait for enough work to be done so that it merits the mobilization of a full-on batching plant. And so it's a total different concept. We actually scaling down on the production facilities so that there's many more of them. But the total amount of material that can be produced now with local in situ aggregate, sometimes there's a granular material that is suitable. You don't need to do all these high-end particle size distribution mix designs with it. It's something that you mix it together and it works. So one of our biggest hurdles now is working backwards for all the road ministries to they say it works. They see it works, but now they need to know why does it work. And you have to be able to repeat and quality control. So it's meshing all this. We stumbled on something, and wow, it has a massive impact, but it still needs to be integrated into the new world. So we're busy with that, but we're rolling out, I think, at least 12 plants this year.
And just in terms of, can you give us an idea of how big you guys were, say, last year, and then how big you guys think you'll be by the end of this year?
I think it's, we were, depending on which region, but in the Southeast Asia or in the Australasia, Oceania region, we were maybe 10 people, and now we are already 60, 70 people. And I think in a year's time from now, with the associated, because in every region and territory, we take on an existing player that's already in the market, in the industry, so that we can ramp up as quick as possible. So we're sharing with people as we roll out. I think in, a study we did for some grant applications here shows that we'll be 1,500 people by the end of this year in the group. And that's just in Australia. We are now talking to interested parties all over Europe, and in America, we already have committed rollouts of much bigger plants in America now. And it's all. So
what's this? This means super exciting. What does that mean for the biochar community? And can they keep up with demand at that scale? I mean, this is the kind of dream come true scenario. And at the same time, is the biochar community ready for it? And if not, how do they get ready?
I think everybody has been being part of all these biochar institutes and organizations. I have picked up that everybody is about the deriving or figuring out how can you scale up. Everybody wants to scale up, but and there's 1,000 different plans, but everything is hampered all the time with capex and the amount of investment money needed, because pyrolysis is not cheap. Right. So we tackled it from another point. We created a demand. We don't put up our own pyrolysis plants. We're going into joint ventures with some people doing that. That is so that we can perhaps do some of the modification for the construction of biochar during the pyrolysis or torrefaction process. So that's again, it's a game changer, but that's coming. At this stage, we create a demand. And if you have 1,000 people running little Kontiki kettles or something somewhere, burning all the waste on their farms, burning waste in municipalities, of course, we have to minimize and make sure that we keep control of the emissions. But we started creating the demand for biochar in Western Australia, which is nearly a third of the size of Australia. And there's now already 1,000 ton, more than 1,500 tons of biochar available any given time.
Nice.
And
that's fantastic. That's kind of what we would hope to see, right? Is that instead of having to solve for every aspect of the hierarchy, you can just say, "Hey, I'll buy it at this price," and people will go, "Okay."
The system is there because there is so many torrefaction pyrolysis plants standing around idle, or plants that has got the opportunity to be with low cost converted into something that can pyrolyze or torrefy anything. Those plants are there. Once you create the demand for the material, then the industry follows. I think in the near past, people trying to create the industry so that they can supply a demand. This is the other way around now. We created the demand so that the pressure is on. And
Yeah.
we now see, we see biochar costs ranging from $120 a ton to $450 a ton.
Mm-hmm.
Up until before we started using this in the construction industry, the prices all hovered up there in the many, many hundreds, because it's clean feedstock, clean process,
Right.
clean application. This world needs everybody, the waste that you throw down your chute at home, that needs to be pyrolyzed.
Yeah, there's part
If
of
it cannot be,
I think it's a really interesting idea, right? Is this idea of there's all the idea of like waste into value, right? And you see a lot of this stuff in terms of methane and capture of energy. And after talking to you, I started thinking about maybe there's a way to see like a waste into sequestration, right? And maybe you don't, maybe you're not going to have lots of really, infinitely cheap and abundant resources that are also clean. But if we could pyrolyze things that weren't as clean, and you talked in the previous conversation, you brought up like some bioremediation waste that you were like, this is no problem. Like we can seal this into a road and then we can turn our waste into roads.
Yeah, there's so many municipalities and cities sitting with thousands and thousands and hundreds of thousands of tons of heavy metal contaminated biomass or bio-waste, because all our sewage systems and stormwater systems are contaminated with heavy metals and PFAS and all kinds of stuff. What do we do with this material? Just the process of trying to clean that up is, that's emissions. All that every single thing you try and do with it, the moment you handle it, there's emissions. So if we stick that through a pyrolysis process, we recover all the energy from there, because there's a lot. There's not only the carbon dioxide, it's the methanes and everything else that's sitting in there. We recover that energy in a clean, emission-free process. And byproduct biochar, if people are worried about it being not so clean, let's stick it in the road.
Yeah.
Don't have to go into the agricultural field. Let's leave the clean wood chips for the clean process, and let's get the soil carbon sorted out. We have to do that as well. Right. But we are sequestrating a factor 10 or 15 more than, and we're doing it in a commercial way already. It's not a concept that's still sitting on a laboratory bench somewhere. Right. We are doing it, and that's the exciting part. That's what gets us up every morning.
well, Andre, I could talk to you for hours, but I want to make sure that I'm respectful of your time as well. And so why don't we wrap here? But how do people who are interested in what you're doing follow along, keep up with what you're doing and the progress that you're making?
Well, I think at this stage, there's actually two sides. The one side of it is people, we get a lot of requests now where people have a problem. They have something that is a big problem and a headache for them, and they say, can you solve this cheaply? It's everybody is cash strapped and COVID, etc. And we actually have done on many sides. We have helped people with serious environmental related problems with materials that we can make inert and make something usable out of it. And on top of that, it becomes carbon negative when you install it. On the other side of it, there's the need for the bigger size industry, even Microsoft and Tesla, and all these guys. They're buying up credits left, right, and center where they can buy a credit. So they're offsetting the dirty things they're doing with clean credits that they're buying from this side. So that's another debate. But the requirement or the need of customers that come to you and say, we need to expand, but we need to get our total carbon footprint down for the operation. How can you help? And this is not only about doing their road for them now that's carbon negative. It's also putting a future plan in place to avoid emissions and to start with low emission processes, purely because we have the products that can facilitate that. And on top of that, then offset, if you have to do something dirty somewhere, let's stick some extra biochar in there to make it, to neutralize the fact. Our logo and slogan is, let's go carbon negative together. That's what we are driving. Let's do it together.
Well, so that sounds, I mean, that sounds really great. Obviously, we're all rooting for you. And so I'll look forward to following up later this year with you. And thanks so much for chatting with us today.
I appreciate it. The good work you're doing. We need to get you all over, and you need to become a celebrity. We will help wherever we can to do that. It's important.
I appreciate that. All right.
Thank you,
Take care,
Peter.
Andre.
And super. Thanks.